Before we dive into the nitty-gritty of machine learning and deep learning, I want to stress how important it is for everyone to participate. Honestly, just sitting back and listening won't give you the full experience.
Totally agree. When you toss your ideas into the mix or even ask a simple question, it makes the whole learning process more dynamic. Plus, there are participation points at stake, 15 of them in fact. So, let's keep things interactive.
All right, let's set the basics. We hear machine learning or ML a lot these days, but what does it really mean in practice?
Well, machine learning is essentially about teaching computers to spot patterns in data, kind of like when you learn to recognize faces or voices. The computer looks at structured data, finds rules, and starts making decisions based on what it's seen before.
That's a great comparison. It's very much like studying for a test with a really organized set of notes. The structure helps the algorithms sort everything out.
Exactly. And that's why spreadsheets like Excel are a perfect fit. Each row and column has a clear meaning, so the computer knows right where to look for answers.
Now, deep learning takes things up a notch. Sometimes people get these two terms mixed up. What's your take? How do you see deep learning standing apart from plain old ML?
Deep learning is like the brain's more advanced cousin of machine learning. Instead of just working with structured tables, it thrives on unstructured data. Think images, video, or raw text. Its power comes from having multiple layers of processing, just like our own brains.
The brain analogy really helps. With all those interconnected neurons and layers, it's almost like having lots of mini experts working together at lightning speed. That actually reminds me, our brains are pretty amazing with this parallel processing. When you look at someone's face, you instantly notice eye color, hair, shape, all at once. How does deep learning mimic this?
It's fascinating. Deep learning uses artificial neural networks inspired by the brain. Each layer in the network acts like a specialized expert. One might focus on edges in an image, another on colors, another on textures, and all those decisions get combined in the end.
And just like your brain, they work in parallel, right? That's why deep learning can recognize a face in a crowded photo even if it's turned sideways. Funny you say that data comes in all shapes and sizes. There's structured data, like those neat Excel files, and then there's unstructured data, like messy images or free-form text. Why does this difference matter?
Because traditional machine learning loves structure, it needs to know exactly what to expect in each cell. But deep learning specializes in tackling the wild stuff, like photos that aren't lined up, or text full of slang and typos. That's where neural networks shine.
So if you're wrangling with photos, deep learning's your tool. But if it's financial statements structured all the way, machine learning can ace it. Let's bring this to life. Imagine you want an AI to spot koalas in a bunch of animal photos. How would that work using deep learning?
Great example. You'd have different experts in your neural network. One might focus on koala noses, another on ears, another on eyes. Each gives a score, like, is this a koala nose? And passes it to the next layer, which makes a bigger decision based on all those inputs.
And after looking at tons of photos, the network learns which features really matter. Maybe the nose is a giveaway, so it adjusts how much weight it gives to each part. You mentioned the network gets better over time. How does it actually learn? Is it just trial and error?
Pretty much, yes. At first, it just guesses. If it gets it wrong, there's a process called backward error propagation. The network tweaks its weights, learns from mistakes, and tries again. With enough rounds, it becomes a pro at recognizing koalas or anything else.
That's kind of like how we learn to ride a bike, mess up, adjust, and eventually you just know what to do. Something you said earlier got me thinking, does deep learning actually understand things, or is it just building connections?
Great question. Deep learning isn't about comprehension like humans experience it. It's all about connections, linking patterns and associations, not grasping meaning. Philosophers call this connectionism. It's different from truly understanding, but it's powerful for pattern recognition.
So the network doesn't know what a koala is in the way we do it, just gets really good at connecting the right dots. Now, here's a classic debate. Should we use machine learning or deep learning for a specific task? How do you pick between them?
It boils down to your data and your resources. If you have a giant pile of unstructured data like thousands of images, deep learning is ideal. For smaller, tidy datasets, classic machine learning is faster and more efficient.
That makes sense. Plus, deep learning can get expensive. Sometimes it's overkill for a simple job. Shifting gears, let's talk about the guts of deep learning. There are three major architectures: feed-forward, recurrent, and transformer. What sets them apart?
I love analogies here. Feed-forward is like making a smoothie. Ingredients go in, smoothie comes out. Recurrent networks are more like taste testing a stew and adjusting as you go. Transformers, though, are like having a super memory. They can recall details from much earlier and connect them in complex ways.
And those transformers are behind all the buzz with things like ChatGPT. Their attention mechanism lets them focus on the important words or details, even if they're far apart. Could you unpack how the attention mechanism in transformers works? I hear it's what makes them so powerful.
Absolutely, attention is like a spotlight. Imagine reading, "The cat sat on the mat because it was tired." When the AI sees it, attention helps it realize it refers to cat, not mat. It highlights what's relevant so it can keep track of context even across long stretches of text.
That's wild. It's not so much understanding like a human, it's building complex webs of relationships between words. And that's what makes language models so strong. Getting down to earth, once you're ready to build, what tools and hardware do you actually need for deep learning?
You'll see platforms like PyTorch or TensorFlow. Those are the big names in deep learning frameworks. But the real star is the GPU, or graphical processing unit. Without that heavy-duty hardware, training a serious neural network just isn't practical.
And GPUs don't come cheap. Luckily, cloud computing lets you rent them now. No need to drop thousands on a gaming rig just to train an AI. Let's bring it all together. Why has deep learning shaken up the world of AI so much?
Because it finally let computers tackle messy, unstructured data images, text, audio at massive scale. That leap, plus powerful hardware, opened the door to things like self-driving cars, smart assistants, and yes, language models that can have real conversations.
So, in a nutshell, deep learning gave AI the muscle and flexibility to handle the kind of messy, real-world information we all deal with every day. That's why it's everywhere now.